Hello Dan, I'm really sorry I cannot be there to celebrate with you, so I recorded this message to tell you a bit about what I've been doing recently. It's been many years since we've seen each other, but I've never forgot what I've learned from you and from your group. Intellectual integrity, honesty, self-reflection, excellence in science. The lessons I've learned really shaped my career, and I tried to pass them along to my own students. So thank you Dan, thank you for all the exciting moments playing with robots. Thank you for all the time we spent writing equations together. And thank you for all the life lessons you gave me. After I left the US and came to the Netherlands, the first thing I did was to build a walking robot. The robots we built were really successful. We used them for research and, more importantly, we used them for education. And it was a big hit with the students. But there was one thing that I felt it was missing. It was, how do we control the gates? How do we change the gates of Rex? Because we know that in the animal world we can do lots of gates, in particular horses. So I posed the question, can we come up with a template that represents gates and their transitions? Consider this simple equation. Suppose T1 is the touchdown time of leg 1, and suppose L1 is the liftoff time of leg 1. Then we know that the touchdown time has to be equal to the liftoff time plus the swing time. Now let's look at this other equation. The liftoff time is a function of the touchdown time plus the stance time, but if we only lift the leg when we allow the other leg to touch down, then we have to say that the liftoff time is the maximum of the touchdown time of leg 1 plus the stance time and the touchdown of leg 2 plus the double stance time. So it becomes very interesting because we can compose the equations for a biped in terms of synchronization of legs. Now, if you notice, all these operations are maximizations and additions. It's a nonlinear dynamical system, but if we pick a different algebra, for example, the max plus algebra, where additions are maximizations and multiplications are additions, then our system becomes linear. In fact, it becomes max plus linear. So if we look at the big picture, what we get is a max plus linear system. Is this a template for synchronization? Is it the simplest representation we can find for switching gates? Well, it turns out that the key is on the A, and if we shape the A in different ways, we'll get different behaviors. Tripod gates, quadruped gates, pentapod gates. Also, it becomes very easy to compose all these gates and make smooth transitions between all of them. Here's a little video of a robot accelerating, and see if you can hear the gate transitions. Another nice consequence of the Max Plus modeling is that you're creating constraints on the time schedules. So if you hold a leg and you keep it in place, it will delay the time schedules of the other legs and the robot doesn't fall down. Also, if you reach the limits of your actuators, because of these constraints on the synchronization, the gates will remain stable. We can use synchronization to synchronize everything, not only the legs, but multiple robots. So with the results we got, we wrote 2 papers. The first one we wrote it for the robotics community. And the second one, we wrote it for the controls community. But what would Dan say? Dan would say, it's great that you have all these tools for synchronization, but you're missing the anchor. So we went, worked hard, and tried to find a way to build anchors systematically. And we got a dynamical robot synchronized with the schedule generated by the Max Plus algebras, and it worked quite well. After many years at university, I left to join a startup company of university colleague. We built Leah, a robot which was developed for the elderly or people with problems in locomotion. In particular, Alzheimer's can affect the locomotion of people. and our robot was very successful in supporting them and improving their quality of life. So I joined another startup of another university colleague, but this time we're building control systems to support installing windmills offshore. What we're trying to do is to reduce the installation time, thus reducing the costs of installing wind energy. We've demonstrated that switching from a jack-up vessel to a floating vessel, you can reduce the installation time by 40%, but this requires very sophisticated control to balance the piles. The controls problem is actually quite interesting. Imagine you're sitting on a boat and you're holding a stick with one hand. Your job is to balance the pile upright while the vessel is moving against the waves. The only challenge here is that this pile weighs 3,000 tons. Well, I don't want to take more of your time. I hope you enjoyed the brief slides I've shown. Thank you again, Dan. It was a great time, and I look forward to see you again in the future. Bye-bye.